I think we are live.
Okay, are we live?
I think.
Okay, can anybody in the chat box confirm whether our voice is audible? अरे थोड़ा बिजी हूँ थोड़ा बाद में कुछ कर रहा हूँ.
Okay, so yeah,
Okay.
today we'll be discussing about this Codeforces contest that happened just recently, actually.
Yeah, yeah.
Uh, just finished recently, which is Codeforces round 748. Right. So, Ivan, how was the contest for you?
Yeah, it was fun. I got a bit stuck in one of the problems. I just did a silly error, which I later realized. But overall, the contest was good. The problems were good.
According to me, like it was my, I did not perform very well in this contest.
Yeah,
Actually, one of
yeah,
my very bad performances in Div 3.
yeah.
Right.
Like some of the questions were a bit tricky.
I got stuck in D2. Yeah, I got stuck in D2.
Yeah,
What about you?
yeah, I got stuck on E. Like I later realized I was kind of doing a silly mistake.
Yeah, so can somebody on the chat actually confirm whether this screen is visible or not?
Okay, I guess the screen is visible.
Yeah, visible. Okay, okay.
Okay.
So before actually starting the problem solutions or about the thought process, I
Yeah, yeah.
would like to introduce you to the our new YouTube channel, which is Code Era. Right? You can see the link in the description of this live stream. So in Code, Ivan, can you please open Code Era YouTube channel?
Okay.
So basically, this is our new channel. In this channel, my our motive is to uh, post solutions and these post contest discussions. Yeah, first video.
Yeah,
Yeah, yeah, this channel
yeah.
actually. So in this channel, we would be actually posting editorials of Codeforces and doing post contest discussion like this. So this is our first time doing post contest discussion.
Yeah, yeah.
So let's see how it goes. So yeah, I just want to introduce you to this new channel, which is Code Era. Yeah, I think Ivan, we should start discussing the first problem now.
Okay.
So, how was the contest for you guys? How was the contest for you?
Like
How was the
you can
contest for
just
you?
comment on the chat.
Yeah, you can just write something. Yeah, I think meanwhile we can start with the problem.
Okay. Okay. So this was the first problem. Should I read through the problem?
Yeah, yeah, sure. Please read the
Okay.
problem.
So in the problem, it is okay. I will just first read through the question and then we'll shall discuss. The question says the election in which three candidates participated had recently ended. The first candidate have received A votes, the second one received B votes, and the third one had received C votes. For each candidate, solve the following problem. How many votes should be added to this candidate so that he wins the election? That is, the number of votes for this candidate was strictly greater than the number of votes for any of the candidates. Okay, and please note that each candidate, it is necessary to solve this problem independently. Okay, okay. So like for each of the candidate, we have to solve the problem independently. Okay, great.
Correct, correct.
Okay. So what it is said that let's assume that the first candidate has got A votes, the second candidate have got B votes, and the third candidate have got C votes. And for each one of them, that is for one, and then two, and then three, you have to separately solve the problem. That is, for that candidate, we have to increase the number of votes. Let's say, firstly, we are doing for number one, so we have to increase the number of votes by, let's say, x, such that a plus x will be greater than b and a plus x will be greater than c. and we have to do this say similar process for both for again for person 2 and 3 also.
Correct,
So
correct.
okay.
What should be the thought process while solving this problem? Like, let's say I've just read the problem. What should be my thought process?
Okay, like
Like,
since
what's your
yeah, yeah,
what was your?
like my thought process was that like for like when I'm considering for let's say person number 1, which
Mhm.
have let's say A votes, then I am left with B and then C votes. So what I just basically need to do is either A, if A, for instance, if A is already greater than B, and if all is A is already greater than C, then I am done. Or if that's not the case, then whichever be the maximum of B and C, eventually I need to make A equals to B, that maximum value that I will be getting plus one. Am I making sense?
Yeah. So basically, the point is, let's say if A wins, if A wins the tournament, so he should be having like greatest vote, right?
Yeah, yeah.
Maximum number of votes. Let's take any example. Let's say if A is having 5 votes, B is having
Okay.
some some votes. B is
Let's say
having, let's
B
say,
is having
five
seven.
votes.
Okay.
Yeah.
Okay, like five.
Correct.
Like five, B is five and C is seven.
Yeah.
So
Then what
in
should
this
be the answer
problem,
for A?
like
What
for
should be the
A,
answer for?
for like it has five, but we are observed to observe that it has less than C, and of B and C the maximum is seven. So we have to somehow increase five to eight.
Correct. Correct.
Then when we make it eight, then it will be greater than both B and C, and we will get the answer.
Yeah.
Okay. So like what we can do is for each of the players, we can actually greedily check out. Like for instance, like for one, we will which have value A, we will check out both two and three, and we will store the maximum of these two value, and just finally we will check now. Finally, whichever the maximum value will be, uh, plus one, or the value that is coming from A. So
Correct.
this like we will take the maximum of these two values, and then this new maxima, and for the first case the answer will be simply this maximum value minus A. Am I making sense?
Yeah. Why we are doing minus A? Because
Because we
the
need to
problem.
increase, right? Because we
Yeah.
need to increase from like from A we have to reach up till max. So we
Hmm.
need to increment it by we need to keep on increment, so the number of increment will be given by the max minus A, like eventually the max value that we'll be getting from this equation, and this max will
Correct.
be coming from this part. And we can do the similar thing for again 2, and then again separately for 3. Like we can kind of do this greedily, and eventually we will get the answer for all the 3 cases.
Correct. So yeah, I think for doing this for every 3 cases, for A, for B, and C makes sense, right?
Yeah, yeah, yeah.
Correct. Correct. So anybody else having any doubts in first
Okay.
problem? It's kind of straightforward, right, Ivan?
Yeah, yeah.
First problem.
Yeah, yeah, yeah. Okay, let us just see through the chat box if anybody is having. Okay, dev team, you are writing max minus a plus 1. See, here I have already taken max plus 1. If you are able to see, so you do not need to put that max minus a plus 1 later. Can you just clarify which max are you talking about? The first max?
Max minus A plus one. Okay.
I'm a bit confused which max. Okay, 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 clear. Okay, great.
Okay, Ivan, should I discuss the second problem then?
Yeah, yeah, sure. You can go ahead.
Okay, cool. Uh, this this true. Yeah, correct. I think is my screen visible, Ivan?
Not up till now. Yeah, yeah, yeah. It's now.
Okay. So let's discuss problem B. Okay.
Okay.
So first of all, what problem B says actually, instead of just reading the whole statement, just focus on what problem B says. Problem B actually says you are given an integer n. Okay, you are given an integer n, and the range is actually having from 1 to I think 118, I guess,
Yeah,
25
yeah,
to 118, 25 to 118.
yeah,
Now
yeah.
what you can do is in one operation, right? In one operation, what you can do is you can remove one digit from this n. What does it mean? Let's say if n is 529. In one operation, what you can do, you can either remove 5, so it will become 29, or you can remove this 2, so it will become 59, or you can remove this 9 and it will become 52, right?
Yeah,
Does
yeah.
it make
Makes
sense?
sense. Yeah, yeah, yeah.
Okay, so basically the problem states that what is the minimum number of steps to get a number such that it is divisible by 25 and positive.
Okay.
Okay, and it is guaranteed that for each n occurring in the input, the answer exists. So what is the meaning of this line? Ki for each n in input, okay, in input, the answer always exists. Now let's say if I tell
Yes,
you
yes.
ki n is 26, right, and you need to actually do some operations, you need to drop some digits, and after that the remaining number, right, the remaining number or maybe the result should be divisible by 25. Okay. Now in
Okay.
this case I don't think so it is possible, because since 26 is not divisible by 25, correct? Now let's say
Yes, yes.
if I drop this 2, so I'll be with 6. Now 6 is also not divisible by 25. Let's say if I drop this 6, now I'll be left with 2. So 2 is also not divisible by 25. So for some n from 25 to 118, there can be no answer possible. But it is given that the input they will be
Yes, yes,
giving
yes.
you, for those inputs, for every input it is possible somehow. We don't know,
Yes, yes.
but for every input they will be giving you, right?
Yeah, yeah, yeah.
Every n. But for every input they will be giving you, it is always possible to make a number which is divisible by 25.
Yeah, yeah.
Okay, so
Makes sense.
let's see how.
Okay,
So
like
example
do the
is,
number 25 give you some intuition?
yeah, so first of all, basically what was my thought process? Okay, the first of all, I thought, okay, we have a number, right, n, which is
Mm-hmm.
having 18 digits, right, 18 or 19 digits,
Yeah, yeah.
something like that. Now let's say the number is 1, 2, 3, 4, 5, 6. Now I need to drop some digits, right? Let's say if I drop this 3, if I drop this 4, and if I drop this 6, and if I drop this 1. So we will be left with this 25, correct? Because
Yeah.
in one operation, what I can do, I can drop a digit from this n. So we'll be left with 25, and I'll say, okay, this 25 is divisible by 25 for sure. And
Yeah,
my
yeah.
answer will be 1, 2, 3, 4 operations. Because I've done 4 operations, right? Correct?
Yeah.
Okay. So what was my thought process? So I thought, okay. So basically, for a number n, we are doing some operations, okay, x operations.
Okay.
We are kind of reducing that number, right? Because we are dropping one digit off every time. So we are kind of reducing that number, right?
Yeah. Hmm.
So what I think is, okay, let's say we have 18 digits in our number. So the number can be up to 118, right? So
Yeah, yeah.
118 will be having how many digits? 1 and 18 zeros, so 19 digits.
Mm-hmm.
Just one number of 19 digits will be having less than that, right? N is actually less than or equal to 118.
Mm-hmm.
So in one case, we'll be having 99999 up to 18 nines. So I thought, okay, we have a number n which is having 18 digits, right?
Okay.
Now, let's say the digits are 1, 4, 5, 7, 8, 9, something like that. And I need to remove some digits. I need to remove
Okay.
some digits, and the resulting number should be divisible by 25. So I thought, okay, this 18 looks very small. Can we try out all possibilities?
Yeah, yeah,
Right.
makes
I
sense.
thought, can we try out all possibilities? So you'll say, how? How will we find out all possibilities? So I'll say, we actually need to remove some subset, right? Some subset of
Yeah,
this
yeah.
indices. Let's say the indices is 0, 1, 2, 3, 4, 5. If we are talking about digits
Mm-hmm.
of this number, we need to actually remove some subset, right? So can we check all subsets? So I thought, okay, 2 to the power 18 doesn't look that bad.
Okay.
We can do this. And for every subset, we'll just remove the digit, right? We'll just remove the digit, and then we'll check whether the required number is divisible by 25 or not,
Okay.
right? But then I thought, okay, is there anything better than this approach? Then I thought, okay, what are the numbers that are actually divisible by 25? So they are 25, 50, 75, 100,
Yeah, yeah, yeah.
then 125, then 150, then 175, then 200. So I came to a actually conclusion that I just need to check the last two digits.
Yeah, yeah, yeah. Absolutely.
What say?
Mhm. Yeah, yeah. Because eventually either you have a 25, 50, 75, or 00, which basically depicts 100.
Let's say we have a x number x here, and the last digits is, let's say, 00.
Mm-hmm.
Can we write this something like this, ki x into 100 plus last digits?
Yeah, yeah. Makes
Let's
sense.
say the last two digits are d1 and d2. Can we write this as, can we write this number, which is x, some digits, some prefix of this number, then
Mm-hmm.
two large digits, let's say
Yeah, yeah.
d1 and d2. Can we write this as this, x into 100 plus d1 into 10 plus d2? Can we write this?
Yeah, yeah.
I'll say yes, because x is a prefix, some prefix of this number. If we are
Okay.
thinking of this number as a string, some
Mm-hmm.
prefix.
Okay.
Now I say, okay, or maybe I can say x into 100 plus d1 d2. This is also integer.
Yes, yes.
Now let's say if this has to be divisible by 25, right? Then what I'll
Mm-hmm.
say, ki this modulo 25 should be 0,
Okay.
right? Now, and by using arithmetic, uh, modular arithmetic, we can actually just uh, take this inside, right? So we'll say, okay, x into 100 modulo 25 plus d1 d2 modulo 25 should be 0.
Yeah,
What
yeah.
say?
Mm-hmm.
Now this part should be already divisible by 25 because we have multiplication by 100 here, right?
Yeah, yeah.
X
Makes
times
sense.
100 should be divisible by 25 because we have
Yeah, yeah.
multiplication by 100.
Yes, yes.
What about this? What about this number? This should also be divisible by 25, right?
Yeah, yeah.
So now for
Absolutely.
d1, d2, we have only four possibilities. They can be 00, they can be
Mm-hmm.
25, they can be 50, or they can be
Awesome.
75.
Yeah, yeah. Absolutely.
Why? How actually I'm able to conclude this? I just, what I did during the contest, I just write the table of 25, right? 25, then 50, then
Yeah, yeah.
75, 100, then 125, 150, 175, 200. If you do this, you'll observe that last two digits are these four possibilities only. Correct?
Yeah, yeah.
Correct. Last two digits are these possibilities, four possibilities only. So we
Yeah, yeah.
just need to check, we just need to check for each possibility. Let's say I have somehow got these two digits,
Okay.
right? Let's say for this number 1, 2, 3, 4, 5, 6, 7, 8. And if I talk about this second possibility, 2, 5,
Okay.
what I'll do, let's just quickly find 2, 5, right? So
Mm-hmm.
I'll start from here. I'll say, okay, this is 5, no, this is 5, no, this is 5, no, this is 5. I have found first digit,
Yeah, yeah.
correct? Now I'll search for 2 now, right?
Okay.
So I'll search, this is 2, no, this is 2, no. Is this 2? I'll say yes. So we have found
Okay.
out this 2, 5, right?
Yeah, yeah.
Now what we can do is, if we have to actually, if we want it, just 2, 5 should be the last, should be at last place. We need to
Yeah,
remove
yeah,
these guys. We need to remove these guys. Correct?
yeah. In the guys in the middle and the guys after 5.
Yeah, correct. The guys in the middle and the guys after 5, the digits, right?
Yeah,
So
yeah.
basically ये digits को remove करना होगा,
Mm-hmm.
right? And then this prefix, we don't need to change this prefix.
Yeah,
Why?
yeah. But before
Because
2,
if we,
everything is fine.
yeah, why? Let's call this prefix x again. So we again will have this number x25. Now this will be divisible by 25 as I discussed. Getting my
Yeah,
point?
yeah, yeah, yeah.
So yeah, that's how I did it. So if I want to show you the code, let's look at this. Let's look at the code. The code is I just created a vector of string possibility. We have four possibility 0 0 2 5 5 0 and 7 5, right?
Okay.
So Ivan, can you check if anybody is having any doubt in the comment
Yeah, yeah,
box
yeah,
or
yeah, yeah.
yeah, please check. Then I'll move forward.
I guess no one has posted any queries regarding this question as of now.
Okay, okay, cool.
I guess you can go ahead.
Yeah, sure. So basically, what I did is we have four possibilities. Now, for every possibility, I'm checking what is the minimum cost, right? What is the minimum cost to make, let's say for this possibility, to make 0 0 at the end? What is the minimum cost to make 0 0 at the end? What is the cost to make 2 2 5 at the end? What is the cost to make 5 0 at the end?
Yeah, yeah.
And if I have these four costs, I'll just take the minimum, right? This is what I'm doing. I'll
Okay.
start from the rightmost point, right? So what I did is I take the input as a string. So if the string, if my input is something like this, 1, 2, 3, 4, 5, 6, 7. So I'll
Okay.
start from this point, okay, rightmost point.
Mm-hmm.
Now I'll try to find 0, 0, two zeros basically
Okay.
as soon as possible, correct?
Okay.
तो
Yeah, yeah. Makes
यहाँ पे तो
sense.
कोई भी 0 0 मिलेगा नहीं.
Uh-huh.
We won't find any 0 0 here. So in that case, actually, my code will store all of this. Like will actually count cost as
Okay.
all of
Okay.
this.
Okay.
Because
Okay.
let's say if answer is equal, so somehow in चार possibilities में से, right, we'll be getting some answer right from one possibility at least,
Yeah,
if
yeah.
answer is possible,
Yeah, yeah.
correct?
Mm-hmm.
So basically, for every possibility, I'm counting. If for
Okay.
to
Okay.
make
Okay.
0 0 at the end,
Yeah, yeah.
what is the cost? To make 2 5 at the end, what is the cost? To make
Okay.
5
Okay.
0 at the end, what is the cost? If we have this cost, I'll say just take the minimum. Just take the
Okay.
minimum
Okay.
of C1, C2, C3, C4, right? And this is what the code looks like. For every possibility, I'm checking what is the cost to
Okay.
create these two digits at the end. So whenever so basically this code, it will do. First, I'll check whether I found out first digit or not. What is the first digit?
Mm-hmm.
First digit is this D2. अगर मुझे D2 मिल गया है तो फिर मैं चेक करूंगा कि D1 मुझे मिल रहा है कि नहीं. जैसे ही मुझे
Yeah, yeah.
D1 मिल गया तो बस दैट्स इट. हमने दो D1 D2 बना ली लास्ट में. अब इनके बीच के काउंट करना है, लास्ट के काउंट करना है बस. This is what
Mm-hmm.
my code is doing. And after that, for every possibility, I'm taking the minimum. Right? I'm taking the
Okay. Okay.
minimum. So I think this should be clear.
Okay.
In this problem, actually, you just need to observe कि last two places पे सिर्फ four possibilities ही हो सकते हैं. 0
Yeah,
0
yeah.
2 5 50 and 75.
Yeah, yeah.
और कोई possibility possible ही नहीं है. If we are talking about 25, कि divisibility by 25. ठीक है. If you know this, then this problem is just straightforward,
Okay.
right?
Like you can also do the problem through one pass also, but that's
Yeah,
that won't affect much because
yeah.
inevitably you are only checking 4 possible outcomes. So
Mhm. Correct. So in one pass, oh, basically you will be in one pass only. You will be checking for zero
yeah, yeah,
zero
yeah, yeah,
two
yeah,
five
yeah.
seven.
0 0 and
Yeah,
2
correct,
5 and
correct,
7.
correct,
Yeah, like you
correct,
can
correct.
also do that.
Yeah, correct. Okay. We can do this. So I think that should be the solution for second problem, right?
Okay. Yeah. Like if
In
anybody have
second
any doubt, you
problem,
can ask in the chat regarding
yeah,
anything related to the second problem.
hmm. In second problem main thing is कि just knowing कि यार लास्ट में तो यही possibilities हो सकती हैं, these
Yeah.
four
Yeah.
possibilities. अगर तुमने ये प्रॉब्लम को इस पे रिड्यूस कर लिया, then it's straightforward, right? So I think yeah, that should be it for second problem. Okay. Now, Ivan, will you discuss the third problem?
Yeah. Yeah. Sure.
Okay.
Is my screen visible?
Yeah, your screen is visible.
Okay. Let me just read through the third problem once.
Yeah, I don't think so. You should read the whole entire problem. What you can
Okay.
do is
Okay.
you already know ना कि
Yeah. Yeah.
problem
Yeah.
क्या कर रहा है. So you can just explain. That would be much better.
Okay. No, like if somebody haven't gone through the problem, then it will be very beneficial for them.
Yeah, yeah, sure, sure, sure. Then
Okay.
please read.
Okay. So in the problem, it is mentioned that there are one cat, k mice, and one hole in the
Okay,
coordinate line.
wait. There is
Okay.
Ivan,
Okay.
wait. Actually, there are some comments in the,
Okay. Okay. Okay.
okay.
Okay.
The comments is, can you please explain your idea for number 120057? Okay, cool. I think Ivan, I should share the screen again.
Yeah. 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 Sure. Sure.
Please take care of the comments, right, Ivan?
Okay. Okay.
Okay, let me share my screen. What is the comment? Can you please read it for me? One
Let
comment
me
was,
see.
why moving from right to left? One
Okay.
comment was something like this.
Like.
So see, basically, uh, you want what you want is कि the last two digits should be these four possibilities, right? There's 002550 and 75. Now let's say the number is 120057 or something. Now, first of all, your first motive is to make 00 at the end. At the end, since you need at the end, you should move from right. Na, you should check from right. Let's talk about this possibility. If you have 1200, then some random things. Let's say 57432, then some 00, and then some 12. Now let's say if you want, see, basically you want to actually do this in minimum steps. So
Okay.
you want to make 00 as last two digits, right? 00 as last two digits. This is one motive. Second motive is you want to do this in minimum number of steps. So see here, this 00 is possible. First case. Second, you can also make these two zero zeros as also possible. Now see, tell me one thing. If I create these two as my last two digits, these two zeros, then my cost is nothing but removing these two guys. Then my cost is nothing but now. If I don't move from right to left, then let's say I decided to make these two guys as the last of the required number. Then my cost is nothing but these suffix, right? 1 2 3 4 5 6 7 8 9. I have to remove all of them. Getting my point? That's why we need to actually move from right to left to do to make 00 at the last as like in minimum number of moves, right? Because let's say if some zeros are here, you have some things. Some zero are here, you have some things. Then which is more beneficial to you, making these two as last or making these two as last? Making these two, right? Because let's say if you are making these two as last, then your cost is nothing but this guy, these suffix size. But if you are making these two as last, your cost is nothing but this entire suffix, right? This entire suffix length. So that's why I'm moving from right to left to get these two digits as quickly as possible. to reduce the number of moves as well, right? Because what I was trying to find out, if let's say if I want to create 0 0 at the last, what is the minimum number of moves to make 0 0 as last digits. Then I'll do similar things with 2 5. I'll do similar thing with 5 0, and I'll do similar thing with 7 5. Now let's say these costs are C1, C2, C3, C4, and I'll just take the minimum out of it. Because I have no problem whether you create 7 5 as last, whether you create 5 0 as last, whether you create 2 5 as last, or whether you create 0 0 as last, right? Even has the doubt actually
Yeah, yeah, yeah.
resolved.
Yeah, yeah. He said he has got it.
Okay, cool. So I think I should stop sharing now, but since you are discussing the problem C.
Yeah, yeah.
Okay.
Is my screen visible?
Yeah, your screen is visible.
Okay. I will just once again skim through the question. So
Hmm.
we are given in the question it is said that there is one cat, k mice, and one hole in the coordinate line. The cat is located at the point 0 and the hole is located at the point n. All mice are located between the cat and the hole, and the ith mouse as like is located in between 0 and n. Okay. In 1 second, like in 1 second, the following happens. Exactly one mouse moves to the right by one. If the mouse reaches the hole, it hides. Like basically, you can say that if it reaches the hole, it kind of becomes safe. That is, it won't be eaten by the cat. Then, after every move of one mice, the cat also moves towards the right by one. Okay, and if in the new cat's position, if there are few mice available, then he kind of eats them all. Okay. Okay, so like basically what we are kind of given in the question is, so initially the cat is located at location 0, and let's say a hole is located in the location n, and in between 0 to n there are mice situated at, let's say, x1, x2, x3, and dot locations. And it's also mentioned that in one particular location there can be multiple mice. Okay.
Hmm.
So
Correct.
okay, so like just as I while solving the contest, the first intuition that came to my mind is, why not send the mice which is the closest towards the hole first. So basically, if this kind of extends to, let's say, x of let's say m, so my intuition was, since this being the closest to the hole, why not send it to the hole first, and then eventually sending, then next I will send the x minus 1 mice towards the hole. And then go on like that until kind of the cat reaches a point, let's say x of m minus 2, from which the cat has already eaten it, so I won't be able to kind of move it towards the hole. So this was the very basic kind of intuition that kind of came to me during the contest, and
Hmm.
I
So
kind of solved. Yeah, yeah.
this
It's kind of very
so this
greedy.
is this is a greedy problem, right?
Yeah, yeah. It's kind of very greedy. Like like you, like in greedy problems, sometimes you need to go with the very basic intuition only.
Correct. So basically, your intuition was just send the
Yeah,
closest
yeah.
mice first.
Yeah, yeah, closest mice towards the hole first, and eventually also
Okay.
kind of keep on bringing the cat towards this direction. And if for instance, if
Correct.
the
Correct.
cat kind of crosses the position x1, then the mice that were present in x1 won't be able to go ahead.
Correct.
And
Okay.
similarly like that, so it kind of what I did was, I kind of had a used two pointers, one that was for the mice that was going towards the right, and one that kind of was started from the last mice and it was going towards the left. And eventually I was kind of checking that whether I will be able to send that mice towards the hole or not. And subsequently each time I, let's say, it took X amount of time to reach the hole, I was also increasing the cat distance by X. And all the other mice that fall under X from this point, I was kind of considering them as they were getting eaten by the mice. So like it was kind of the very like it was the first intuitive approach that came to me, and I coded it, and it kind of worked.
Okay.
Okay, I wish you like. Do you have any kind of other ways of doing it?
What I did is I actually got this intuition, but I was not sure whether this is correct or not.
Okay,
So
okay.
what
You can
I
share
did
your screen
is,
and tell about it.
yeah, sure.
Okay.
Maybe I think for this problem, this intuition is also correct, I believe.
Yeah, yeah.
So this can you please show the code for this?
Okay, okay.
So first of all, his intuition was he just start from the rightmost mice, right, and say, check whether this is possible or not,
Yeah, yeah.
whether we can send this mice to the hole or not, right?
Is my code visible?
Can you please zoom out a little bit?
Zoom out or zoom in?
Zoom in, sorry, zoom in.
Oh yeah. Just give me a second.
Maybe you can show your code on Codeforces.
Okay.
I just search for your profile.
Yeah, yeah. Is it good enough?
Yeah, it is visible. Can you please
Okay,
just
okay.
zoom in a little bit? Yeah.
Okay. Is it good? Like only the solve part is the where the main thing is happening.
We need to also sort, right, in this.
Yeah, 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 yeah. Like obviously, like since kind of after every iteration, your cat will also get incremented by distance x, right? So you will always try to have the least lesser access towards the left and the more greater access towards the right, which eventually kind of leads to the sorting.
No, no. First of all, the fact is that the input is not sorted. The
Yeah, yeah, yeah,
array
yeah, yeah.
that you are given is not sorted. So
Yeah,
you
like
need
it
to
is
sort
not
this first of
mentioned
all.
that like it is not mentioned that we will be given and sorted.
Yeah, correct, correct, correct. Yeah, I'll share my approach as well.
Yeah, yeah.
Don't
So
worry,
like it is
Raksha.
basically kind of a
Yeah.
simple two-pointer approach.
Because
So
even
like
I thought
there isn't much logic.
this won't work. Okay.
Okay.
Why we are sorting? Okay.
No,
We
no,
are
you have to
sorting.
sort, right? Because
Yeah, please show the sample inputs.
okay.
See, basically, if you are going from rightmost point to leftmost point,
Mm-hmm.
right? If you are going from rightmost point to leftmost point, you should have the sorted positions, na, on
Yeah,
x-axis.
yeah, yeah,
On
yeah,
x-axis, if you're going from rightmost point to leftmost point, you should have
yeah,
these
yeah,
as sorted. So you're
yeah, yeah,
since the input given is not sorted, we have to sort it.
yeah,
That's
yeah,
the point. That's the
yeah,
point I
yeah,
was making.
yeah, yeah. Yeah, like you like as I mentioned in the solution, like you will always try to get the nearest point towards the hole to get inside the hole first.
Just do your algo with some example. Okay, can you just run your algorithm on first sample input, Ivan?
Okay.
Just copy the first sample input
Mm-hmm.
on whiteboard, on open board, sorry, and just
Okay.
do the dry run. I think that would
Okay.
be
So
much
like
helpful.
like okay. So just kind of write down it.
So this 10 is nothing but n, the
Yeah, yeah,
rightmost point, or you can say
yeah.
the
Zero and n.
coordinate of a whole.
Okay. Okay. So like after sorting, we will get 4, 4, 5, 7, 8, 9, and the whole is here
Yeah, see,
to
that's
where
the
we have to
point of
reach.
sorting,
Yeah, yeah.
right? Because
Because
you want to go through.
like
Yeah, please continue. Ivan, please continue.
like eventually like you always want the nearest point from where the mice is available to go towards the hole first. So like since 9 is the closest to 10, so practically you will always want him to reach the hole first.
Yeah.
And like for instance, like since it takes a distance of 1, so like by the after it reaches here, the cat will also kind of jump from 0 to 1.
Yeah, because 9 wants one operation to reach to hole,
Yeah,
right?
yeah, yeah, yeah,
So, and at the same time, we'll just increase the cat pointer by 1.
yeah, yeah.
Correct.
And eventually now we have 8. 8 will require 2, the like two distance you need to move towards the hole. And
Hmm.
subsequently the cat will also get an increment of +2, and now its new distance point will become 3.
Yeah, correct.
Like it is 3, still it is less than 4, so like we don't have to remove anyone as of now. Now as we are in 7, so from 7 we need a distance of 3. So if we, okay,
Hmm.
it is gone. And then if we take 7 to the hole, now the cat will get an increment of distance 3, so it will become 6. Now we can see as it has reached the point 6, this 3 cats are already eaten in this process, like in this traversal from here to here. So like these 3 cats won't be available to reach the hole. So our answer
Correct.
becomes these 3 points, which is 3.
Basically, the point is while checking, you are moving something like this, first
Yeah.
check whether the cat is behind or not. Right? If cat is ahead of you, the cat already eaten you, right? The
Yeah,
cat
yeah, yeah,
already eaten
yeah,
this
yeah.
mice.
That makes sense.
That's
Yep.
the point. So
Yeah, yeah.
basically, while checking for every point, just check what is the position of cat. If it is behind, that's okay. We can go. But if
Yeah,
it
yeah,
is ahead or on the same position, the cat actually already eaten this mice. है ना? Isn't
yeah,
it?
yeah. So like for that you can just kind of have a two-pointer approach.
Correct, correct. So basically, he maintained 2 pointers, one for cat, one for the current mice that we are
Yeah, yeah.
checking. Let's say if the current mice is here and the cat is here. Now, if cat is behind, we can actually move this mice to the hole, right? And we can update the
Yeah, yeah,
cat. We can update
yeah,
the
yeah.
cat's position as well. Now we'll just do the same for every mice. We'll just check how far we can go.
Yeah, yeah. That's kind
Yeah,
of
I
what
think
the greedy
that's for
approach was.
the greedy induction. Yeah.
Hmm.
Actually, my approach was also greedy, and it is
Okay.
actually I just did some overkill by using binary search. I just do binary search on
Okay,
answer
okay.
and doing the same like you just did. So maybe
Okay,
I
like
can
you,
just
okay,
do
okay,
it.
like you were also doing the two pointers along with a binary search.
Yeah, correct. So I just
Okay.
overkill this problem.
Okay, okay,
So
okay.
basically, we can answer this in one pass, right? As just you did. Also, can we can do is create an array of size n to keep track of mice at particular position and initialize value by 0, and on reading input can increase the mic at the position by 1. Okay. Also, we can do is create an array of size n to keep the track of mice at particular position. Okay, makes sense. And initialize value. Then what will you do? Dev team, what will you do after that? Like there should be some procedure na? Because you have to choose one mice every second to increase its position. Okay, actually, okay, cool.
Hmm.
Ivan, let me explain my approach.
Okay.
I'm sharing my screen.
Yeah, yeah, sure.
Please look at this comments, right, Ivan?
Yeah, yeah, yeah. No, no. The
Please take care
last
of the
time
comments.
actually I had some issue on my end. That's why the comments were
Yeah,
not
okay, cool.
kind of appear.
So basically this is the cat's position, right? Let me create a cat. Oh, I'm not good in
Oh,
drawing, but let's
you don't
let's say
need
this
you
is
don't need to
cat.
draw a cat, man.
Okay, cool. This is x-axis, right? Now this is our position of hole, which is n, and cat is at 0. Now one, two, three, 4, 5, 6, something like that. Now let's say we have a mice here, we have a mice here, and we have a mice here. What I did is I actually thought, ki, okay, let's say I binary search on answer. Binary search on answer. How binary search on answer?
Okay,
So
like
what we will do,
where you finding the last x from which you can reach the whole, something like that.
yeah, basically first observation should be ki, let's say if your answer is 3, let's
Okay.
say if you are able to pass 3 mice to the hole, then
Hmm.
you should be clear that you should take care of last 3 mice, right? You should be actually taking these mice to the hole, because it is more easy.
Yeah,
Why?
yeah, makes sense.
Because let's say if you have some mice here, some mice here. Now let's say if I tell you कि यार 3 mices को लेके जाना है होल की तरफ, ठीक है, यहाँ पे एक हमारा है, सो विच इज मतलब या तो मैं बोलूँ कि 3 ये वाले यूज करने हैं या फिर 3 ये वाले माइस यूज करने हैं, सिंस ये वाले माइस ज्यादा पास में है होल से,
Yeah, yeah.
so it is actually easy to actually just take these 3 mice to the hole instead of taking these 3, right? This is first observation.
Yeah, yeah.
Now what I did is I binary search on answer. I did
Okay,
binary
okay.
search on answer. Now I checked ki whether let's say the range is nothing but we can have zero elements, zero mice is possible, and we can have all k mice possible, right?
Makes sense.
Now what I'll do is I'll just check the mid element. I'll check whether this mid is possible or not. The typical thing that we do with binary search. So let me show you first my code, right, to make it more clear, I think. So let me open my code first. Yeah, it was here. As you
Well,
can see,
Rohan, like you can do it with a simple greedy approach also.
yeah, even I did greedy only, like
Yeah,
while
like
checking
even
whether this
he
mid
need
is
greedy,
answer
but
or not.
yeah, yeah.
I did only greedy, and you can also do this in simple pass.
Like
So
you
I'll
can do
just
it in
checking.
one pass.
Yeah, I'll just checking whether this mid is answer or not. If this mid is answer, this check function will tell me whether this mid is answer or not. So tell me one thing, with just the basic actually approach of binary search. Let's say we have 0 mice, 1 mice, 2 mice, 3 mice, 4 mice, 5 mice, 6 mice. Total 6 mice are possible. Now let's say 0 is possible. So I'll say 0 mice, passing 0 mice is possible. Passing 1 mice is possible. Let's say passing 2 mice is also possible. 3 mice is also possible. Now 4 is not possible. 5 is not possible. 6 is not possible. Actual scenario. Now let's say I'm at 2. I check whether this 2 is possible or not. So I'll say yes, this is possible somehow. So I'll move in next half because I should find the rightmost t. The basic binary search on answer trick that we do. Binary search on answer, right? Now I cannot discuss in brief what is binary search on answer, right? Because we are just discussing the solutions.
Yeah,
So
yeah.
you can say ki I just binary search on answer, and now greedily I find out whether this answer is possible or not. Now how to find out whether this answer is possible or not? So I just check. Ki, let's say if answer is 3 that I was querying about, and I'll just check the last 3 mices, and I'll just check whether we can actually move these 3 mices to the hole or not using the same
Yeah,
greedy
yeah.
technique that,
Makes
that
sense.
Khan did, right? So I just overkill my solution.
Yeah,
That's
yeah.
it. And there is nothing to share in this solution, but still it works because I'm just doing binary search on answer and will actually eventually tell me the most optimal answer. So I think we can also do this in simple pass that Ivan did. But yeah, that was my approach. Right. Ivan, will you
Yeah,
please
yeah.
discuss D1 solution quickly?
D1.
Yeah, D1.
Okay.
Okay, just to know how you applied binary search. Yeah, the basic thing that we do binary search on answer. We just do binary search on answer, right? And then just check whether this answer is possible or not. If this answer is possible, we make our decision either to move left or to right. In check function, you just found the rightest mice now. In check function, I'm just checking whether this can we actually have this answer. Can we have 3 as an answer or not? So to get 3 as an answer, yeah, I'm checking for rightmost 3. Correct. I'm checking whether we can actually move rightmost 3 mice to the hole or not. Correct. Yeah, please even discuss even fast. We
Okay.
are running
Okay.
actually
Yeah,
out
yeah.
of time.
Okay, okay. How
and
much time has it been?
I have to discuss E also.
Yeah,
E is
yeah, sure.
actually,
Okay, okay. I will just skim through D1 then. Okay. So like polycorp has an array of n. N is given as even, and we also have an integer, positive integer k. Okay. And then polycorp kind of have an operation in which you can take any index and reduce the number in that index by k. Okay. Okay. And it is mentioned that after polycorp perform some of the operations, possibly zero, it turned out that all the numbers in the array become the same. Okay, and we have to find the maximum k which is possible in such a situation, in which if we kind of take the k and reduce any of the chosen numbers by k n number of times, eventually all the elements in the array will become the same. Or print minus one if like print minus one if no such answer exists. Okay, let's
yeah.
check
So
out.
first, let's discuss about the -1 case, right?
Yeah, yeah.
कि कब आ सकता है -1? Like when we can get -1. So yeah,
Uh,
please explain the solution once. Fine.
like eventually when you kind of go through the solution, you realize that minus one isn't a very okay. I will just kind of see it.
Yeah.
Like you can have k as one, right? So like if you have k one, like
So
eventually you can.
first actually explain the problem, na? First explain
Yeah,
the
yeah.
problem statement. What does it state?
Okay,
Then
okay.
when we'll discuss about our solutions.
Okay. Like you have an array of n integers a1, a2, an, and then you have an element k. And in one operation, you can choose any of the indexes, and you can reduce. Let's say you choose the second index, and you can reduce the number by k. And you can choose the same index a number of times, and you can choose any out of the index. And eventually, after some operations, you just want that all the elements become equal. Let's say all the elements becomes equals to a. Like this is kind of the basic overview of the problem. You need to find the maximum k which you can take and do this operation a number of times on any of the indexes, and you want all the numbers to become equal.
We first out. Can we do the
Okay.
operations any number of times?
uh,
Yeah, it is actually
yeah,
given.
yeah.
I was just checking. Yeah, yeah.
Yeah,
So the thing is, we can do the operations any number of times.
yeah,
Now
yeah.
you have an array. You have an array, and what you can do is in one operation you can actually decrease any elements value by k. This is for first one operation, okay? And you can do this operation any number of times,
Yeah, yeah, on any
any number,
indexes.
on any indexes. Now eventually your goal is to make every element equal.
Yeah, yeah.
Yeah, please discuss. Please discuss.
Okay. So like for let us consider any two elements, let's say a1 and a2, and let's say that finally all the elements in the array becomes equal to x. So what you can say is from a1 to reach x you need to decrement it. Like you can use the operation k. Let's say I use it alpha one times. Okay, sigma one time. Oh, sorry. Let's say I use it for alpha one times. Like for alpha one times, I use the operation on a1 and so that it becomes equal to x. Similarly, let's say I use the operation for alpha two times in order to reach x. Okay, so basically from here, what you can see is if I took the difference of these two numbers, it comes k of alpha 2 minus alpha 1. So basically, you can from this observation, you are able to see that if we take the difference of any two numbers of the array, then eventually that difference should be uh, divisible by the number k we choose. Okay.
Correct. Yeah, difference should be divisible by k. Correct.
Okay. So you can kind of take this analogy ahead, and you can observe on that. Let's consider the smallest element of the array. A of let's say it's a1 is the smallest element of the array, and since any two numbers the difference of any two numbers should be divisible by k, so like all the remaining elements a3 a4 dot n an, if you kind of take the difference of these two, it should be divisible by k. If we take the difference of these two, it should be again divisible by k, and so far and so forth. If we took these two, it should be again divisible by k. So from this observation, we're able to kind of conclude that like if we like w- somehow we can always kind of choose any of the numbers and bring that number value towards the lowest element present in the array. And moreover, if we show, since all the differences are divisible by k, why can't we just directly find the GCD of let's say a2 minus a1, a3 minus a1, so on, an minus a1. And won't this GCD give us the answer? Because since k was divisible by all the differences, the GCD is also divisible by all the differences. So like basically the answer k can be given by the GCD of this expression. And for instance, the answer for the first case can like will not be -1, since eventually GCD, like the smallest GCD available, will be 1. So like the minimum possible value in this case will be 1.
Okay, so what if every element is I got this actually solution,
Yeah, yeah.
but so the solution is ki let's say for every element if we are doing
Mhm.
alpha 1 operations, alpha 2
Yeah,
operations, something like
yeah, yeah,
that. So we got a conclusion that their differences should be divisible by k, right?
yeah, yeah.
Okay, okay. Then after that,
Okay, like so we can directly find a GCD of all the differences. Like we can take the smallest element, like we can find the smallest element, and compared to that we can find the GCD of all the remaining elements with the difference of the smallest element.
hmm. So first of all, you are doing ki first of all you are making every element as the smallest element, right?
Yeah, yeah, yeah.
Okay, yeah, yeah, correct. Okay,
Mhm.
okay, yeah, I think it makes sense.
Mhm.
Correct. And why taking GCD? Why
Because
taking
like
GCD?
k should be divisible through all the differences, and like to find that
Correct,
we can
correct.
just do the GCD of the numbers.
Every difference should be divisible by k, right? We can say
Yeah, yeah,
that
yeah. That's
because
the
because
basic
the
idea.
because the difference is nothing but some alpha times k.
Yeah, yeah,
So basically, for all the distances, we need to find the number k, which is actually all these distances should be divisible by k, and k should be
yeah,
as
yeah,
large as possible.
yeah, yeah,
So it is nothing but the definition of GCD, right?
yeah,
Greatest common divisor.
yeah, yeah.
Yeah, I think yeah, that's what we want to do, and that's what we
Yeah,
have
yeah,
to do in this problem.
yeah. Like you can also do one thing is that like you can kind of choose any, or like for instance you can choose the maximum of the elements and the minimum of the elements. You can keep this difference, and you can kind of find out all the divisors of this difference and check out whether like the divisor which we got will suffice, like will like can that be the value of k or not. But it will be kind of it will kind of overdo the problem. Like we can directly find the GCD, like it will be very simple. Like
Correct, yeah,
finding
makes
divisors
sense.
and all, like it will
So
overdo the problem, like overkill the problem.
can you share the code? Can you share your code? Can you
Oh,
show your code?
like I kind of find the divisors, so like don't think it will,
Okay, okay.
like it won't be necessary, like isn't necessary enough to kind of find the divisors. Like you can directly find the GCD. Like after the
Hmm.
contest I kind of realized that I could have done it through GCD, and it would have kind of reduced the time complexity by a lot of margin.
Correct. Okay.
Okay, are there any doubts for this question?
Let me check. Let me check
Okay. Yeah,
any
yeah,
doubts. We can make all elements equal to one element of array. Yeah, I think that's what he did.
yeah, the smallest element basically.
Yeah. Correct. I don't think so. There is any. Let me discuss the problem E then.
Yeah, yeah, sure, sure.
Okay. The problem I believe is actually easier than D2 because I got stuck in D2.
Yeah, yeah, yeah,
Problem E was kind of very straightforward according to me. If you know basic tree, if you know the definition of tree, so basically the prerequisites to solve this problem nothing but knowing what a tree, right?
yeah,
Problem
yeah.
E. So problem E is nothing but the prerequisite for this prerequisite is nothing but knowing what a tree. knowing what a tree is, how to store a tree, right? Maybe just simple or basic understanding of tree. So what the problem actually states that we are given a tree. Okay. Now a tree is nothing but a graph, a connected graph having no cycles, right? Having no cycles and it should be connected.
Okay.
So let's say we are given a tree and it is not rooted. It is not rooted. By this statement, what does it mean? Ki in most of the problems involving trees, what you do is you actually make a root. You actually root the tree to actually do this problem easier, right?
Mm-hmm.
Basically, let's say if you're given a tree something like this, if you just create this node to root, then the tree will look something like this.
Yeah, yeah.
So it is actually simpler in visualization, in visualizing the problem. If you actually root that tree, right? Well, then if you have this root, then you can do many things. You can start a DFS from here. You can start a BFS. You can do some dynamic programming on trees, something like that. But in this problem, you are not given the rooted tree, and you don't need to even root this tree, because then it will actually uh, what it will actually the root can also be the leaf, and according to this problem. So let me explain the problem a little bit.
Mm-hmm.
So let's say if you are given the tree something like this. Now, in one operation, in one operation, what will happen to this tree? All the leaves, right? All the leaves. Now, how to define a leaf? All the nodes that are just connected to only one guy. Let's say this element is just connected to this guy, right? So this is a leaf. What about this? This is also connected to only one, just this. So this is also a leaf. What about this? This is also connected to only one element. What about this? This is also a leaf. What about this? Is this a leaf? So I'll say no, it is connected with one, two, three, four elements, right? It is not a leaf. What about this guy? Is this a leaf? So I'll say no, because this is connected with these two guys. So the definition of leaf is the vertex that is connected to only one vertex. Okay. Now basically trimming of this tree happens. How? So you have a tree something like this, and let's say you have some things. Okay. अब फर्स्ट ऑपरेशन में क्या होगा? फर्स्ट ऑपरेशन में बेसिकली सारे जो लीव्स हैं वो ट्रिम हो जाएंगे. So you'll trim all the leaves. So first of all, identify what are the leaves here. This guy is a leaf. This guy is a leaf. This guy is a leaf. This guy is also a leaf. This guy is also a leaf. What about this guy? Is this a leaf? No. What about this? Is this a leaf? No. What about this? Is this a leaf? No. Now in one operation, like let's say first operation, okay? Every operation, what will happen? You'll trim all the leaves. You'll cut all the leaves. So in first operation, what will happen? You'll cut this guy. Okay? You'll cut this. You'll cut this leaf. You'll cut this leaf actually, and you will cut this leaf. Okay. So this is a operation look like. See, in one operation, you just actually take the tree and just trim out all the leaves.
Yeah, yeah.
So this is what first operation is. Now in second operation, you will do the same thing. So let's talk about second operation. So you'll do the same thing. This is a leaf. This is a leaf, right? This a leaf? Is this a leaf? What say? This is not a leaf, right? Because it is connected to two guys. This one and this one. This is not a leaf. Yeah, you can please check for the doubts, right?
Yeah,
If
yeah, yeah.
having any doubts. In second operation also you'll cut these leaves. So just cut this, just cut this. Left with a tree having one vertex. So in third operation, you'll just cut this vertex. Okay? And you don't have any tree right now. So in further operation, you'll do nothing. So the problem actually tell you a tree. The problem gives you a tree. Gives you a tree. Okay, let's say the tree looks like anything. Let's say this. And it also gives you, the problem also gives you a K. It gives you K after K operations, how many vertex will be present in the tree, because in every operation you are cutting the leaves, right? So you are cutting some part of tree, you are cutting some vertex. So the problem asks you ki after k operations, right, how many vertex are kind of alive in the tree. right? How many vertex are actually present in a tree, right? So does it make sense, Ivan?
Yeah, yeah,
Does the does my explanation of the problem make sense?
yeah, yeah, absolutely.
Okay, so the solution is actually just straightforward. You just need to simulate this process. Straightforward, right? Let's say if you have this tree, it is not rooted, right? I'm kind of making it kind like a rooted, but this is not a rooted tree. So yeah. Now in first operation, what will you do? First operation, you will remove these leaves. First, second, third, fourth, fifth, sixth, seventh. Now, how will you identify which vertex are actually leaves, right? So basically, you can store a degree. Degree is just a basic concepts in graph theory. So degree is nothing but how many elements are connected from this guy. So for this, the degree is one because just one guy is connected. For this element, the degree is one. For this, what about this guy? One. What about this guy? Two guys are connected. So the degree is two. Similarly, for this, three, one, 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 one. And for this guy, one, two, three, four, five, six. Now, in one operation, you will just remove all of the nodes that are having degree as one because degree one means leaves. So you'll just remove these guys. Okay. Now, while removing, what will you do? So basically, if you are removing this vertex, you should change this degree as well, na? Because now this degree is nothing but 5 because one neighbor you have removed, right? One neighbor of this guy you have actually removed.
Yeah, yeah,
So so but just simulate this process and kind of update every neighbor's degree, and eventually you'll reach, after k steps you'll reach the tree, or maybe you can count the number of alive vertexes. So let me just show you by a normal example. What is the first test case? First exam sample test case here. First sample test case is a very big test case, but still let's try. So
okay.
first
Like
test
there is
case.
a doubt. Like
Huh?
like Boner Boy mentioned that like he has solved the problem by running a DFS, and he took the center of diameter as root. I don't know what does mean. That he's speaking that
Okay.
taking like he take the center of diameter as root, and if
Mm-hmm.
this diameter is even, then you will get two centers, and you can just add another vertices adjacent to these two centers and run the DFS.
Okay, so first of all, Boner Boy, the one you asked, he's a pro. So
Okay,
basically,
okay.
there can be multiple ways to solve a problem, right?
Yeah, yeah, yeah,
And
yeah,
I'm sharing my approach because
yeah, yeah.
there can be multiple ways, and he might be actually correct because he's a pro. So I'm sharing my approach, what I did, and this is actually the simplest approach that I could think of during the contest. So
Yeah, like this
basically,
approach is kind of similar to finding a circle in a graph using BFS.
what this approach, my approach, or what? The,
Yeah, yeah, your approach, like finding a like circle in a graph using BFS. Like in
according
there
to
also we
me,
kind of have the in degrees and all.
according to me, this approach is nothing but just doing what the problem says. Just do what the problem says, right? Just remove all the leaves. That's what the problem says, right?
Yeah, yeah. No, no, I'm just kind of stating that it kind of like the process is similar to like that problem.
Okay, that's great. Should I create this whole graph? Let's just create some
I
simple
think
graph.
you can take a smaller example.
Yeah. Let's just create a simple graph. Now, first of all, I should actually count the degrees. Degrees for every vertex. So for this guy, the degree is 4, 1, 1, 1, 1, 2, 2, 2. Now, first of all, what should I do? I should just remove these, remove all of these which are having 1. So let's say before starting the simulation, just check how many vertices are there which are having degree as 1. And I just kept them in a vector. Okay. Now, in first operation, you should remove these guys. So what do you mean by removing? You should actually decrement your alive
Yeah, yeah,
vertices counter by the number of leaves. First of all,
yeah, yeah,
first step. So here number of leaves are one, two, three. So let's mark it one, two, three, four. Right, four leaves are here. Right.
yeah, yeah.
So first of all, let's say the alive counter was at the start. The life counter was 8. Now you should actually decrease 4 from it because you are removing 4 leaves in first operation. So now the life count alive vertices will be 4, right?
Yeah, yeah,
Now what you should do? So as I already said, we have actually kept all the leaves in a vector. Now one by one I will be removing them. By removing,
okay.
what does I mean? By removing is if I'm removing this guy, I should change the degree of its adjacent nodes, right?
Yeah, yeah, makes sense.
Because if we are removing this, let's say we are removing this, then I should decrease this degree by 1,
Yeah, yeah,
right? So that's what you have to do. That's what you have to do. And for every iteration, you just need to check. Let's say if something like this happens. Let's say this is a leaf node and this is a leaf node. Now you remove this. Now this becomes a leaf node, right? Because
yeah, yeah,
first its degree was 2. When you remove this guy, its degree becomes 1. So you need to check if the degree becomes 1, just add it to the leaves
yeah, yeah,
vector,
makes sense.
right? And then in the next operation, you will start simulating leaves, which I did just here. So I'll
Yeah, yeah.
just share the code. Don't worry. So I think yeah, that's what the implementation looks like. Just simulate what the process says, right? So let me just quickly show you my implementation. Yeah. So first of all, this is nothing but taking the graph, right? Taking the graph as input, then counting degrees. Let's say if there is a edge between two nodes, then we should count 1 1 to both, right? To both degrees.
Mm-hmm.
Now, before starting the simulation, I have already taken the leaves in this leaves vector. If
Okay.
degree is 1, just push back in the leaves vector.
Okay, I think you could have also used the cube.
It doesn't matter.
Yeah,
Just use anything.
yeah, yeah,
So now we should have to repeat this process k times, right? That's what the problem asks. Repeat this process k times. So now, first of all, if the alive counter is less than or equal to 2, what does it mean? If we have only one guy, it means the process is over because we
yeah,
have
yeah,
to remove it anyways. If we have two guys, means they both are leaves.
yeah.
We have
So
to
yeah, yeah,
we have to remove everything, and the process actually just done. You don't have to do anything after that. That's why
yeah,
I'm
yeah,
just uh, that's why I'm just updating alive to 0 and just breaking the loop because it doesn't matter what you do afterwards because you don't have a tree right now.
yeah, yeah.
After that, right? Now what I'll do, I have created another vector temp to take care of the present leaves. Okay, present leaves before starting this operation,
Okay.
and then I'll just update my alive vertices by the size of this leaf, right? Because I have to remove these leaves, so my alive will actually decrement it by the same amount. And then for every leaf, I'll just checking. For every leaf, since I am removing this leaf, I should update its adjacent nodes, right? I should update the degree of adjacent nodes.
Yeah,
So
yeah,
for every adjacent node, I'm just decrementing the count of degree, right? What I'm doing is, let's say if we have something like this, and this is a leaf node, right? This is a leaf node, and its degree is 2. Now if you want to remove this guy, you have to update its degree to 1 as well, right?
mm-hmm.
Because let's say if this guy has been removed, then now its degree is 1, isn't it?
Yeah, yeah,
So that's what I'm doing. I'm decrementing the degree of adjacent nodes, and if any adjacent nodes is having degree as 1, it means it is the leaf for the next round. Now it becomes the leaf for the next round, right? Let's just consider a simple example. If we have the tree something like this, first of all, the leaves node are nothing but these two. Now, while removing, you have updated the degree for these two guys, correct? You have removed this, you have updated the degree. Now, these guys, since their degree is 1, they becomes your next round's leaf, right? Isn't it?
yeah, yeah,
So that's what I'm doing. If degree of adjacent becomes 1, just push back it into the leaves because I have already cleared this leaves, right? Because I'm
yeah, yeah.
now storing the leaves for next round. And yeah, that's what we have to do. What about the time complexity? Now, some people will actually look. like look into this code and say ki, okay, we are running this loop k times. We are also doing some loops here as well inside this loop. So basically, the time complexity is nothing, but what you will do is the max operations that you will make is nothing but the number of edges. Why? Why number of edges? So basically, if this is a leaf, you'll just encounter it once. Right after that, you'll just forget it
Yeah, yeah.
because in the first round, if this is the leaf, you have to encounter it. After that, you will just remove it. So for every node, you'll just visit two times. How two times? So for this node, you will just actually visit this node actually twice the degree. How twice the degree? So basically, let's say if the tree looks something like this, right? Now for this guy, once this vertex will become leaf, so you'll just update this degree. Now let's say if somehow this vertex also becomes leaf in some round, you'll update again its degree, right? So it is nothing but you are doing two times m operations in total, correct? So if you are having a while loop that runs k times, you are doing some things. If you look closely, you are just doing two times m operations. That's what maximum you can do, where m is the number of edges.
Okay, like one doubt. Like, won't the
Mhm.
time complexity be n plus twice of m?
Yeah, like that's what I'm telling you. Ki n plus. Yeah, it
Like you are
doesn't make
also
sense
visiting the
because
vertices, right? So O of n will also
yeah,
come
yeah.
into picture.
Basically, the time complexity is nothing but big O of m. You can say, right? Like if you
Yeah,
add
it's
here
linear. Yeah,
n,
it's linear. Yeah, yeah,
it's
it's
linear,
linear
right? Yeah,
eventually.
correct. It's linear. That's what I'm trying to say. So yeah, that's
Okay.
what I feel about this E problem. Just simulate the process. What the problem statement says to you, right? Just do a normal simulation, and that's it. That will work. So I think yeah, that's it for discussing about this round. Ivan, do you have anything to say?
No, no, I'm just looking through the chat box. If anybody have any doubts, you can just kind of pin in once.
Once again, Ivan, can you please introduce to the Code Era YouTube channel? Can
Okay,
you
yeah.
please introduce?
Yeah, so basically, like if you want the solution of the Codeforces and CodeCef contest, you can visit Codera. This is an where channel which is kind of completely dedicated towards problems of competitive programming contests. It is a great initiative by Geeks for Geeks to kind of help competitive programmers to learn through contests. So yeah, please visit it, and you can also check out the solutions out there.
And please do share your feedbacks because this is our first time doing something like
Yeah, yeah.
this, doing something live stream, and we'll try to improve, right, in future contests.
Yeah, your
So yeah,
feedback will be very well.
yeah, we are always open to constructive criticism. If you do have any feedback for us, please do leave a comment that yeah, you can improve on this area, you can improve, and we will definitely improve because this is our first post contest discussion, right, Ivan?
Yeah, yeah,
Yeah, okay, cool. So I think that's it. We don't have any doubts. I think we should end the session here as we are
yeah. I
already
think
out of time.
nobody's kind of writing down any stuff as of now.
Uh, yeah. So can we end the session? I think yeah.
Mm,
Let's end the session, right?
yeah, yeah. I think we can end it.
Okay. Bye everyone. Good night.
Yeah. Bye, everyone.